Here we go. This is chapter 1.6, problem 3. The table shows the femur lengths. That femur is that bottom length in your leg, bottom bone in your leg. The femur length and height of several people. All right. Do the data show a linear relationship? If so, write an equation of a line to fit and use it to estimate the height of a person whose femur is 35 centimeters long. Okay. So basically, they're comparing femur length to people's heights. Okay? And what they want us to do is they want to know, is it linear? Basically, is it linear? All right. If so, write an equation of a line of best fit. Oop, there's a typo in there. I need to go fix that. Fit. And use it to estimate the height of a person whose femur is 35 centimeters long. Okay, so basically we have an x coordinate and a y side. Let's see here. The smallest x looks like it's 30. And the biggest x is 50, I think. Yeah. So basically I need to go from 30 to 50. So if this is my x coordinate, my x-axis, this will be 30. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Perfect. This will be 40. This will be 50. Okay. The height, my lowest height is it 141? Okay, lowest height is 141. Is it 195? 195. Yeah, 141 to 195. So we got to count a little bit different here. So we're going to call this one, here's my y-axis. We're going to call this one 140. And I think, can I go 10, 50, 60? Nope, can't. So 50, 60, 70, 80, 90. Yep, that's what I'll do. I'll go by twos. 50, 60, 70, 80, 90, 50, 60, 70, 80. Yeah, it looks like that's what I got to do. So 140, 150, this will be 160. 70, this will be 180. 190. This will be 200 right there. Okay. So this will be 58. Okay, so we got our graph. And next thing we need to do is we just need to plot our points. Well, I'm going to pause and plot real quick so you don't have to sit there and watch me do it. But you need to plot all the points, so give me a second. And there you go. Alright, plotted all the points. I made this one bigger because it's essentially two spots on the same thing. It's that 45, 183 and a 45, 182. But those are. So, first question, does the data show a linear relationship? And I would say, yeah. Yes. The data shows a linear relationship. Let's fix that on. T I O N ship. Okay. It says, if so, write an equation of a line of best fit and use it to estimate. So basically, to find a line of best fit, to estimate one, basically what I'm going to do is I'm going to see how well I can do this with a calculator. You take your ID, take a ruler, and take something and draw a line the best you can down the middle of the graph. So I'm going to try it right like that. Okay? And that's pretty close. It's not perfect, but it's not bad. I mean, if we all did this separately, we would all find different lines. Alright? And basically what I'm going to do from here is I'm going to find two spots on the line, which it looks like this one right here is pretty close to 30, 145. So we're going to call that one 30, 145. That's going to be one of our points. And you just keep looking, keep looking. Oh, 2, 4, 6, 8, 7. This one right here looks like it's at 47, 185. 47, 185. So that'll be the other one. 47, 185. Okay, so those will be the 2 points I use to estimate my line. Alright? So we've got 2 points. Let's write the equation. So, remember, m is delta y over delta x. Changing y over changing x. So 145 minus 185 divided by 30 minus 47. Well, 30 minus 47 is negative 17. 145 minus 185 is negative 40, which just going to leave it as 40 over 17. 17 is prime, so it doesn't go any further down, so we'll just leave it as that. Alright? And to find a b value, basically we just take one of the points, plug that, and the slope in. So y equals mx plus b. I'll pick the 30, 145. I'll pick this first point. So my y value is 145 equals my slope of 40 over 17. My x value was 30. Yeah, I picked 145, 30 plus b. So here we go. 40 times 30 is 120. No, 1,200 plus b. So I need to multiply by 17 and divide by 1,200. So 145 times 17 divided by 1,200 is, I wonder if I can turn that into a fraction. You know what? It's a really crazy fraction, so we're just going to go 2.05 equals b. Okay? What's 40 over 17 anyways? 2.35. So here we go. Your equation is y equals 40 over 17 x plus 2.35. Okay, so there's your formula. Have we answered the questions? It shows a linear relationship. We wrote an equation. And it says estimate the height of a person whose femur is 35 centimeters long. Well, femur is the x value, which we already figured out over there. So, plug in 35 for x. Y equals 40 over 17 times 35 plus 2.35. So here we go. 40 over 17 times 35 plus 2.35 is y equals 84.7. Something's off here. Give me a second, let me see if I can go find my problem. Found it. Okay, so Mr. Hunter's a bit of an idiot, but let's make this nice and quick. So it goes all the way back to right here. Alright. What happened is this is a number that I have to subtract over. Mr. Hunter made a big, big boo-boo. So let me pause and erase everything real quick. Okay, so that's 145 equals 70.59 plus b. Subtract that over, so 145 minus 70.59 equals 74.41. Equals b. That's very different than what we had before. So, let me burn through this real quick. Y equals 40 over 17x plus 70.59. Okay, and they want to know estimate the height whose femur is 35. So I'm going to plug in 35 for x. 40 over 17, 35 plus 70.59. Let me pause real quick. I'll crunch that number. And so in this case, y equals 152.94. So someone with a femur length of 35 centimeters is about about 152.9 centimeters tall. And there you go.